Boy, it got chilly in here, didn't it?
Yeah, sure.
I think we're ready to do number 8 of the Module 1 practice problems for Apologia Chemistry, 2nd edition.
Hashtag not sponsored.
I think we'll just have to blur out your sweater. Can you try not to shake the camera?
Sorry.
Thank you so much. So please read number 8, letter A to us.
What
we're doing here is we're converting these from scientific notation into
decimal numbers.
Yeah, decimal or normal numbers.
Yeah, regular decimal numbers. 6.54 times 10 to the third.
B.
3.450 times 10 to the negative 3.
C.
3.56 times 10 to the 7.
3.56?
Yes.
D.
4.050 times 10 to the negative 7. Okay, so the first one is easy. It's 60.
Remove the decimal.
6,540.
3 to the right. 1,
yes.
2, 3. So we're sticking a 0. 6,540. Okay, with this one, we're going to move the decimal to the left 3 places.
Also easy.
1, 2, 3.
It's just 0.003450.
And we need to express this final 0 because it's significant.
This one is also super easy. Hold on a minute. It's 3 billion.
Just to the 7. 1, 2. So
that's 3 billion.
1,
560
2, 3, 4, 5, 6, 7. 1, 2, 3. 1, 2, 3. So 35 million.
Never mind.
600,000.
It's just a few places off.
Okay. That's why I like to just write it out before I try to figure out what it is.
Totally. Oh my gosh.
Okay, so this one we're moving 7 to the left. So 1, 2, 3, 4, 5, 6, 7.
0.0000004050. And that last 0 is included because it's significant.
2, 3, 4, 5, 6, 4, 0, 5, 0. Very good. Okay. We're going to move on to number 9 and not stop the camera. Will you please read it to us?
Should I wait for you to finish erasing first?
No, go ahead.
Lead has a density of 11.4 grams per milliliter. If I make a statue out of 3.45 liters of lead, what is the statue's mass? So that we start with, that's rho equals, mass equals volume.
So we call it density, right? So density, rho, equals mass
times volume.
Divided by volume.
Over
volume. Okay.
Yes.
So mass divided by volume. So what do we know? We know the density.
We know the volume. So we're going to convert this, before we write down any numbers, we're going to convert that into mass equals.
Right, so that we can set up our equation for what we're looking for. We're looking for mass. So it's easy. We're going to multiply both sides by volume. So we say mass is equal to the density times the volume, right?
Okay, yes.
So the density, 11.4 grams per milliliter. Now let's look at the volume. The volume is in liters, so we can't.
There.
We can, but we want to put it in this equation with the same units as milliliters. So that's pretty easy, of course. We're going to multiply it by 1,000 milliliters per liter. And that's a line there. The liters will cancel 1, 2, 3. So 3,450 milliliters. So 11.4 grams per milliliter times 3,450 milliliters. Our milliliters will cancel, end up with grams, which is, of course, what we're looking for because we want to know the mass. Martin, what is the fantastic answer you get?
39,330.
Right, and it comes out evenly, yes?
Yes.
Of course it does, it's a multiplication. And that's grams. So to express this, let's look. How many significant digits here?
That's 3.
3. How about in our volume?
Well, there's 3.
Also 3. So we should be expressing 3. So we're going to round this to 39,300, right?
Okay.
So let's just do that. Now we're going to express it
In scientific notation.
Write down the numbers so we make it millions. And that, yes, so that will be? I'm going to do it here.
3.93 times 10 to the 4 grams.
1, 2, 3, 4. So the mass is equal to 3.93 times 10 to the 4th grams. Most excellent. Now we're going to do number 10 on to the end here. This is again a density problem. It is your density. Go ahead.
Gold has a density of 19.3 grams per cc.
Hold on.
If a
Density equals 19.3 grams per cc, which is the same, of course, as milliliter, but cc. Okay?
If a gold nugget has a mass of 45.6 kilograms, what is its volume? So first, let's convert that formula into what we want. Let's put that as volume equals density over mass.
Density equals mass
over volume.
Divided by volume. So we want to solve for volume, right?
So we multiply it by m over m.
Well, first we're going to multiply. We can't solve with v in the denominator. V has to come out of the denominator or it's not going to be solved. So say that would be density times volume equals mass, and then volume equals mass divided by density. Okay?
Yes.
So volume is mass divided by density. Let's look at our units and make them agree. We're fine with cc's, right?
Yes.
Yeah, we can end up with cc's. What's that?
You doubt me?
No, I just want to make sure that the book doesn't ask us for specific units. Thank you so much for doubting me. No, you're doubting me. And it's not funny. So don't do it anymore. It's a waste of time. Let's convert these units, please.
Okay, into grams, right?
Right, so that's going to be, so we want grams in the numerator.
45,600 grams.
Just give yourself the favor of setting it up. You have plenty of notebook space.
Oh, yes.
So we move it over 3, so 45,600 grams. Okay, so we're going to say volume is equal to 45600 grams per 19.3 grams per cc. Now, if you remember your math well, you'll remember that I can cancel these out and I'll end up with cc.
Just like magic.
I can do it for you if you want me to. If there's a possibility you don't understand what I just did, I'll be happy to write out the steps, but I'm not going to do them unless you ask me to. Do you want me to, Martin?
No.
Okay. So now we divide this by that. It's obviously going to be somewhere around, 200 something.
2,000.
No, I don't think so.
362 plus change.
No, I think you did that wrong. I don't think you put you did something wrong. It's 45,600 divided by 19.3.
Yeah.
Sorry, just checking. Oh, okay, it is. Sorry. All right, so 2,362, 7, something like that, right?
Yeah.
Okay. How many significant figures are we looking for?
It's like
I had 3.
Yeah.
and this also has 3. So we want to have 3. So we want these 3. So we're going to round here.
Mm-hmm.
So round 62.7 to what? To 60, right? So we're going to say 2,360.
Mm-hmm.
Right?
Uh-huh.
And then what? We're not there yet. And that's CC.
Now with scientific notation. Can I call it nerdy notation? I think it has a ring to it.
Yeah.
Sounds good. Sweet. So in nerdy notation, this would be 2.36 times 0 times...
No, we don't want that. That's too many.
Okay.
We only want 3 sigs.
Yes. Times 10 to the 3rd cc.
Right. Let me ask you, could we express this as liters as well?
Sure.
And what would that be?
We're not going to.
That would just be 2.36 liters,
Yeah.
right? So either of these would be correct.
Sure.
Okay. Well, thank you. That concludes
You're welcome.
Module 1 practice problems. If you have any questions,
All
please
of them.
email him.
Please.